Okay, let's continue what we have stopped for previous lecture. Previously, in example 5, yeah, I agree with you when you do the calculation, if you use the original number, if you use the force attraction 1.49 times 10 power negative 9, you won't get this number. I checked back, there's a typo error in my question. So actually it's not -9, but it's a -8. So if you substitute this number, you change the 10 power negative 9 to 10 power negative 8, then you will get this number. Okay, so I also capture this screen, this page, and I send to the WhatsApp group, right? Just as for the reference for your revision. Okay, yeah. But the steps of solution still remain the same, right? Still remain the same. Okay. What is important in example 5 or important for your incoming assessment? This equation, F net equal to attraction force plus the repulsion force is important. This formula is important, right? And when there is a equilibrium, when you see the question give you the keyword equilibrium, means the net force equals 0. So when you find the net force equals 0, when you find the attraction force already, it's actually equal to your repulsion force or repulsion energy. Sorry, typo error on my slide here. Is not energy, but it's a force. Okay, it's a force. Correction on this one. So when you see the word equilibrium in a question or in a statement, mean the net force 0. So you only need to find one of it. Okay, either find this one or find this one. How you know you can find this one when you're given the number n. If you see the question give you assume n equal to something, the statement will mention, then there will be one portion you need to find the repulsion energy. Okay. We continue with hydrocarbon structure. We stop at here in previous lecture. So the objective for today's class, we intend to conclude chapter 2 and go into chapter 3 a little bit before we end for this week, right? So we have already done metallic bonding. Metallic bonding means you join, not metallic. Ionic bonding means you join group on the left in the periodic table with the one on the right side of the periodic table. Okay, metal plus non-metal, it becomes ionic. Then covalent, it means all the non-metal you combine together. Okay, so for example, hydrocarbon, which is important because this is part of one of the chapter called polymer in the later chapter. Okay, so this is just an introduction. We'll go deep into hydrocarbon later on. Okay, later on. So this slide is introduce you how you draw the structure. So for example, carbon, you know that carbon in periodic table, you have four electrons outside. So we need to share with one electron outside. So it will form one line. So this is a single bond. So carbon, normally you have 4 lines. Either sometimes you will see 2 lines and 2 lines, but you'll see 4 lines. It means that the orientation can be 2 like that, then 2 and then another 2, but total line that you see around carbon will be 4. Okay. The next one, also hydrocarbon category or family, is called benzene, C6H6. So C6H6, are you able to draw the structure by, if you're given the chemical formula? C6H6 means that you have 6 carbon. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Right? And you know that carbon have 4 bonds. 4 single bond means 4 electron outside that it can join with other. It can form with carbon also. Okay, so this is a benzoin, a bit complex. However, there will be one question in your final exam. Right? I already give you tips. You will be seeing this structure in the final question, final exam question. Right? So this is one of it. When you arrange the carbon, this we'll go into arrangement of carbon later, but not in this chapter. This chapter just introduce you. There is a covalent bonding in in the carbon hydrocarbon family. Okay, so this is okay. So they are diagram the A B C D here. A is, if you see straight line, means using straight line bonding notation. You can simplify this structure with this hexagon ring, right? It's called simplified notation. If you see this one, it means this one, including the hydrogen. Okay, if you see this one, it equal to this shape. Then this is the bonding arrangement. This location. And if you see this symbol, it means you have a ring structure, top and bottom. Means it's a stack. You have a stack ring structure. So carbon one ring, carbon one ring, and then this one in the middle. But you can simplify it with hexagon and a ring inside or circle inside. Okay. All right. So what is the material properties for this one? I give you all, but you can read lah. So if you compare to ionic bonding you can imagine as a glass, not glass, carbon, diamond. They are very hard, very easy to break. But covalent bonding, most of it they are gas molecule, like CO2, plastic, all this. So they have a low melting temperature. So how you memorize the properties is that you just log to one images that you familiar with, then you elaborate based on the properties. Okay. So this is another example. It's called network covalent solid, which is you see something like this lah. So this one is a special bonding. It's not fall under covalent or it's not fall under ionic. So it's a very complex structure, like you see. This is diamond structure, right? So you have a silicon with the oxygen. Okay, yeah. So metallic bonding. From the word itself, metallic bonding. Earlier is ionic bonding. We have clear ionic bonding. We have clear covalent bonding. Now we go into metallic. Metallic means metal. Only metals, metal plus metal. So on the periodic table that you're familiar with, you are given the color already. So you only need to match the color with color. But in general, is group 1 and group 2, they are metals. Okay, group 1 and group 2, they are basically metals. Okay. So this is how they group. So metallics, they have a valence electron. They are bond with valence electron. The keyword for metallic bonding is valence electron, as you can see on the simplified diagram here. So you have an ion positive and negative arranged in the sequence. Okay. So when you study this module again, remind yourself that how we design the question in test or final exam. Section 1 will always involve with diagram. Anything being with diagram or graph, then that is section 1. Number 2 is calculation. B is calculation. C is explanation. C normally asks you why or asks you to explain something. Okay, so this, if you see diagram, then you try to have some ideas. You don't need to draw exactly, but when you being told to explain something, at least there's a diagram you can draw. Okay. So let's say copper. Copper. In chapter 3, you'll see something like this. We'll go deep into this structure, but in this case, we just focus on the type of bonding. So metallic bonding, we choose copper. So copper, you have a 12 neighbor packing in this one. So later we will study how to draw this diagram. Okay. Okay, so this is how a simplified diagram draws. So in a copper atom, so you have 1, 2, 3, and 12 atom here. So the valence electron will be running around the gray space here. Okay, the positive one is the positive charge core. Ion core do not move, only electron move. Okay, remember, positive ion do not move, but only the electron can move. The electron outside, we give them a name called valence electron. Valence electron means electron that free to move. Okay, the rest you read, everything that on the screen you can read. So again, the positive core always it defines the attraction, the pulling force, or you can name it as a grabbing force, where they can grab electron. It's like a magnet. Okay. So this is the textbook definition for metallic bonding. So when there is a attraction force between the positive ionic core and negative electron or valence electron, it's called metallic bonding. Okay, so it's when the atoms, you draw this diagram and then you draw, maybe you only need to draw 4, and you draw a box and then you point the space is a valence electron, this is a positive core, ion cores, and then you explain your diagram. One special characteristic of metallic bonding is that they are 3-dimensional and non-directional. They are similar to ionic bonding. As you read, then you look at this table. We're focusing on melting point. So if you study ionic bonding, covalent bonding, metallic bonds, so normally we try to ask, how do we test your understanding? Normally we'll ask you to explain about the melting point. Why the melting point difference between ionic bond, covalent bond, and metallic bonds? Okay, so you can see these are the melting point. So as they get stronger and stronger, the bonding becomes stronger and stronger, then the melting point is higher and higher. Okay. So again, there's a colorful chart earlier that I showed you. That is your cheat sheet. You memorize the colorful diagram with the arrow, go up, go down, that one. You memorize that one. Okay. So that one tell you the size of radius, it tell you the electronegativity, it tell you lots of information there, right? So for example, column number 4, period number 4 on the periodic table. So as the number of valence electron increase, so you know that this This family here, group 1, it have 1 electron outside. This one have 2 electron outside, and so on. This one 3, 4, 5, 6. And this transition one, you know that is a very special category where there is a D suborbit there. This is a S, this is a P, this is a D. So when it comes to level 3, after level 3, remember that your electron sometimes go into the 3D suborbit before it go into the either S or P here. Okay. So the attraction force between positive core is this example. So, for example, copper. If you do the analysis, electron analysis, you will get this number 3D10 4S1. Right. So by now you should able to write this one. Again, assessment will ask you on this one. This one very important. So don't say I didn't give you tips, but this is very important. Okay, so you need to know how to write this one from the periodic table. Then you see this one, the bonding energy, so and so, melting point, so and so. What else? Then the rest is quite high. The rest is quite high compared to that one. You look at this table and then you compare side by side with the periodic table. This one. K, Ca until chromium. You take these slides, compare side by side with this table, you will see the influence of bonding there. Okay. So all this I will go very fast. For pure metals, here is pure metals. They are easily formed, and they deform easily. This is the how they deform. So if you push one, then they will just slide on. They'll just slide on and stick to. They still stick together. They just change the orientation a bit. Okay. Again, metallic bonding, their bonding is quite weak. They are quite weak because the electron is running around. So these are the properties. Easy to form, excellent conductor. Why excellent conductor? Because of the valence electron. Outside got 3 electron outside. We also heat conductor. Excellent heat conductor. What else? Okay. Another category compare to ionic bonding, metallic bonding, covalent bonding. There's one more category called mixed bonding. So you have 4 category of mixed bonding: ionic covalent, ionic plus covalent, metallic covalent, metallic ionic, ionic covalent metallic. So you have a few combination, right? So we only focus on 4. Okay, the rest you read. So this slides, what is important? Why mixed bonding is important? Because there's one calculation formula there. You know that when you study in engineering, we are very likely to ask you about formula. Right? So for ionic covalent mixed bonding, there's one formula, this one. So this formula is to calculate percentage of ionic characteristic or character bonding in compound A and B. So you mix A and B together. You want to know how many ionic character. It will show like how many ionic character inside there by using this formula. So equal to bracket 1 minus E exponential quarter minus 1.4 times XA minus XB squared. So you see, look at one example. What is XA and XB? All right. So where you find the XA and XB, you find using chart. There's a chart given. if this formula come out or this type of question come out, you will see electronegativity chart. Then you know we are actually asking you this formula. Okay, if you don't see any electronegativity chart, then don't use this one. If you also use this one, means you don't understand the question asked, what the question asks you. Or sometimes you see the question asks you based on your understanding in Pauling equation. It also gives you some hints lah. You need to use this Pauling equation. Based on understanding in Pauling equation, determine the percentage of ionic character between A and B. Okay. So let's look at two examples. One is GaAs. GaAs. So if you look at periodic table, Ga is in group number 3. If you look at periodic table, then As is group number 5, right, in a periodic table. So what is group? Group is the vertical column in the periodic table. So this is group 1, group 2, group 3, group 4, and group 5, until group number 8. Group number 8 is the stable element. Then zinc and Se. Zinc is in group 2, Se in group 4, group 6. This is the structures for GaAs or gallium arsenide in semiconductor. So why this one is important nowadays? We can say all the electronics component nowadays, they form by semiconductor. So if you intend to go into a semiconductor company like Intel or Micron, then in your interview you might be asked question something about the material. Okay. So what is another one? ZnSe is zinc selenite. So this is how they look like in the real form. So where does this Zn selenite use? They are used in the solar panel and so on. Okay. Okay, let's look at how to calculate the percentage of ionic characteristics. So you know that GaSa ZnSe just now. So if you see this table in the question or in the appendix, means there's a high chance that you need to use the Pauling equation. So how do you read this table? It gives you electronegativity. It gives you the period, means the orbit lah of this one. Sorry, period is a horizontal component in your periodic table. So what is interest is that you look for the numbers below the element. For example, this is the formula, the Pauling equation, right? So the first one is Ga. Ga, you go to this chart, it show you 1.6. Then As is 2. So you copy these two numbers, put in the solution. So you write XGA 1.6. XB you write 2.0. Or in your answer, you write referring to electronegativity chart. Yeah, this one won't be given. If the question asks you about Pauling equation, right? So there's a marks for this one. If you write this one out, there's a mark for this one and substitution also. So this basically is nothing complex. It's just it's a 3-mark question. Memorize and then you apply it on. Okay. So if you see this diagram lah, if you don't see, then means we not ask you this one. We ask you something else. Okay. So you just copy the number, and then you substitute. How you know which one is which one? How you know which one is which one? GaAs, A is the first one, B is the second one. GA, if GAAS, GA, the front one is A, AS is a behind one, so it's a B. So you take GA 1.6 minus 2, you get negative number, but again, it's a bracket square, so you still get positive. And you have a negative exponential here. So don't forget the negative sign. Okay? Then you times 100. You'll get 4%. 4% ionic character for GaAs. Can you do for the second one using the same approach and try to find the answer? What is the ionic character for ZnSe by using the diagram? Okay, maybe I clear the thing for you. Where is Zn? Zn is this, what is it? Zn. Zn is here. Okay, Zn is 1.6. Se, this one, 2.4. Then you substitute lah. Sa is 1.6 minus 2.4. You press calculator, press. Again, now this is E exponential. It's an E exponential. So when you use calculator, it's a good practice to use the bracket in the calculator. So if I'm using the calculator, how I'm going to press for some calculator, you have this symbol and this symbol, same. Okay, so I will put bracket like this one. Put bracket, and then I use the cursor. Some calculator have this arrow button. You just press whether go back and all this. Okay, just to so that the formula is valid lah. So 1 minus exponential exp. There's a E something. Some calculator you have an E and then the box one. You use that one, and then remember when you press this one, use the bracket. Use the bracket. This one will go inside here. Those advanced one. Okay, then you key in. If you scared of 1.4, you just press in minus 0.25. Then bracket. Then key in 1.6 minus 2.4. 2.4. Then press the square. The square function in the calculator. Square function, you see the x square one in the calculator. Okay, press this one and then close the bracket. Press the bracket. What you get? It should be around 5 something, right? 5%, right? Correct? 14, about there lah. But it's higher than the previous one. Okay. First one you get 4. Second one 15, 14 point something. 15%. Okay, so very easy. This one actually is a free mark if this question come up. It's only test you whether you know how to use the graph only. Okay. Okay. Then the next one you read from the slides. Only ionic covalent bonding, you need to find the ionic character. The other one you don't need. Metal covalent, you read Metal covalent, normally they are in a group number 4A in the periodic table. The rest you read. Then secondary bond, we have primary bond and secondary bond. Okay. Now secondary bond, they are weak compared to secondary bond. What are the example of secondary bond? So normally you will see something like this one, dipole. We call it dipole. So you learn about physics. So physics, you have the word moment. How to find moment? is a force and the distance, right? So you have a reference point and you have force pointing down like that. This is the D, the distance must be 90 degrees along the reference line and the force. Then this one will form moment. Okay. So this one also same. A is an electric dipole. So the moment will be the distance between these two. Q is a charge lah. Then the distance you form moment. Fix one, and then it will either clockwise or anti-clockwise. Then this one is the covalent bonding dipole moment. So this one you have different charges. Two molecule here, different charges, right? Again, I won't ask you this one. Okay, so there's a formula to calculate dipole moment, but same, you just change the parameter, the mu and the q and d. The concept still same. Okay. There's a conversion after, if you see the question, exercise question or your assignment question, you see cm. So sometimes it asks you to, when you work in quantum physics or very for example semiconductor industry, right? You need to do doping and all. So one debye or debye equal to so and so. There's a conversion number there, right? Okay, so what are the example of secondary? You heard van der Waals before, right? Van der Waals, they are electrostatic force. They are very, very weak. They are very, very weak. So all this you read, this one you also read. So example of van der Waals bonding helium, argon, krypton. Normally you see this one, they are group number 8. Okay, they are stable. This one, okay, the group number 8. So why the melting point increase? You see from helium, you drop to radium, this one. You see the melting point, melting point from not dropping, increase. Minus 200 something to minus 70. It's actually increasing from the negative scale. Don't be fooled by the negative sign. It's actually increasing. Don't be fooled by the negative. Okay. The next one, okay, this one I go very fast. This one you read for information. Okay. One special category that we don't test you or we don't ask you is hydrogen bond, but you should be told that there is a hydrogen bonding. All right. So hydrogen bonding, they are very complex. There's an angle between the two molecules. Right. So every time that deal with hydrogen, anything that deal with hydrogen, there are tendency to form hydrogen bonding. Okay. For example, water. Why water behave so uniquely compared to other elements is because also the hydrogen bond inside the water. Okay. So this is the time test for freezing water of water. Water expand when you cool, and sometimes and is able to break the container if you're not carefully, right? So you're able to break the container because of the hydrogen bonding. So water is something special. So you work in the engineering field, sometimes you forget that the water can do something when you when you contain some water inside there, right? So water, it can break lots of container. And once it's break, and then sometime when you arrive at the scene, the water already vaporized. So you might forget about the fundamentals of water characteristics, right? So this is on the troubleshooting when you go to work. Remember that water, actually, they can exert force on the container. This one, when you work in the four-season country, where they have a winter, especially, or you are involved with the car design or petroleum that run a petroleum company that you design the piping, so or underground cable, something like that. So be careful on the characteristics. Okay. So this one you read how the hydrogen bonding, again, I won't ask you in the test, right? Go very fast. So because of the bonding also, it will mix the iceberg float. Okay. So this one, again, if you work in automobile that involved in the cooling system or climate, very freeze, very cold weather application, then you need to be careful. And then nowadays, agricultural, if you work in the a consultant for freezing room for food, then this one also, the hydrogen bonding phenomena also you need to consider, right? For medical also, medical, okay. So these are the breaks or defect that find in the cars and all this. Okay, and road also. Okay, so if you work in a JKR, then maybe when you interview for your professional engineer, one of the panel might ask you, what can you explain why pothole can form in the four-season country, especially, right? Malaysia, because of the Rolly heavy vehicles. But if you go into, but if you go to the Western country, especially those countryside, then you'll see this pothole. This pothole formed because of the ice problem. Okay. The rest you read. Okay, the rest you read. Okay, so we have complete chapter 2. The rest is just a sample of question that you can go and practice. Okay, go and practice. Okay.